Ohm's law is a fundamental principle in electrical circuits. It describes the relationship between voltage, current, and resistance. The law states that the current through a conductor between 2 points is directly proportional to the voltage across the 2 points and inversely proportional to the resistance between them. Mathematically, Ohm's law is expressed as I equals E divided by R, where I represents current measured in amps, E represents voltage measured in volts, and R represents resistance measured in ohms. To understand this law, let's consider a simple circuit consisting of a voltage source such as a battery and a resistor. The voltage source provides the electrical potential difference that drives the current through the circuit. The resistor opposes the flow of current. The greater the resistance, the lower the current for a given voltage. If we increase the voltage, the current will increase proportionally, assuming the resistance remains constant. Conversely, if we increase the resistance, the current will decrease proportionally, assuming the voltage remains constant. Now let's consider a specific example. Suppose we have a 12-volt battery connected to a 30-ohm resistor. We want to determine the current flow in the circuit. Using Ohm's law, we can calculate the current as follows. I equals E divided by R. Substituting the given values, we get I equals 12 volts divided by 30 ohms. Performing the division, we find that I equals 0.4 amps. Therefore, the current flowing through the circuit is 0.4 amps. It is important to note that the units must be consistent when using Ohm's law. Voltage should be in volts, resistance in ohms, and current in amps. If different units are used, conversions must be performed before applying the formula. Ohm's law can be rearranged to solve for voltage or resistance if the other two quantities are known. For example, if we know the current and resistance, we can calculate the voltage using the formula E equals I times R. Similarly, if we know the voltage and current, we can calculate the resistance using the formula R equals E divided by I. Let's consider an example where we want to find the voltage across a resistor given the current and resistance. Suppose we have a 2 amp current flowing through a 10 ohm resistor. To find the voltage, we use the formula E equals I times R. Substituting the values, we get E equals 2 amps times 10 ohms. Performing the multiplication, we find that E equals 20 volts. Therefore, the voltage across the resistor is 20 volts. Now let's consider an example where we want to find the resistance given the voltage and current. Suppose we have a 6-volt battery connected to a circuit with a current flow of 0.5 amps. To find the resistance, we use the formula R equals E divided by I. Substituting the values, we get R equals 6 volts divided by 0.5 amps. Performing the division, we find that R equals 12 ohms. Therefore, the resistance in the circuit is 12 ohms. Ohm's law is a fundamental tool for analyzing and designing electrical circuits. It allows us to predict the behavior of circuits and to calculate the values of voltage, current, and resistance. It is important to understand Ohm's law and its applications to effectively work with electrical circuits. In practical applications, resistors are available in a wide range of values and power ratings. The power rating of a resistor indicates the maximum amount of power it can dissipate without overheating. It is important to select resistors with appropriate power ratings to ensure that they can handle the power dissipation in the circuit. Resistors are also available in different types, such as carbon film, metal film, and wire wound resistors. Each type has its own characteristics and applications. Carbon film resistors are commonly used in general-purpose applications. Metal film resistors offer high precision and stability. Wire wound resistors are used for high-power applications. When analyzing circuits with multiple resistors, it is important to understand how resistors are connected in series and parallel. When resistors are connected in series, the total resistance is the sum of the individual resistances. The current is the same through each resistor in series, and the voltage is divided across the resistors according to their resistance values. When resistors are connected in parallel, the reciprocal of the total resistance is the sum of the reciprocals of the individual resistances. The voltage is the same across each resistor in parallel, and the current is divided among the resistors according to their resistance values. To calculate the total resistance of resistors in parallel, we can use the following formula. 1 divided by R total equals 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3 and so on, where R total is the total resistance and R1, R2, R3 are the individual resistances. After calculating the reciprocal of the total resistance, we must take the reciprocal again to find the actual value of the total resistance. For example, if we have two resistors in parallel, one with a resistance of 10 ohms and the other with a resistance of 20 ohms, we can calculate the total resistance as follows. 1 divided by R total equals 1 divided by 10 ohms plus 1 divided by 20 ohms. This simplifies to 1 divided by R total equals 0.1 plus 0.5, which equals 0.15. Taking the reciprocal of 0.15, we find that R total equals 6.67 ohms. Therefore, the total resistance of the two resistors in parallel is 6.67 ohms. When analyzing more complex circuits with both series and parallel combinations of resistors, we can use circuit simplification techniques to reduce the circuit to a simpler equivalent circuit. This involves combining resistors in series and parallel to find their equivalent resistances. By repeatedly applying these simplification techniques, we can eventually reduce the entire circuit to a single equivalent resistance. Once we have the equivalent resistance, we can use Ohm's law to calculate the total current flowing through the circuit. We can then use the current divider rule and the voltage divider rule to determine the current and voltage in different parts of the circuit. The current divider rule states that the current flowing through a resistor in a parallel circuit is inversely proportional to its resistance. The voltage divider rule states that the voltage across a resistor in a series circuit is directly proportional to its resistance. These rules are useful for analyzing circuits with multiple resistors and for determining the voltage and current distribution in the circuit. In addition to resistors, other common circuit components include capacitors and inductors. Capacitors store electrical energy in an electric field, while inductors store electrical energy in a magnetic field. Capacitors and inductors exhibit different behaviors in alternating current AC circuits compared to direct current DC circuits. In AC circuits, capacitors offer impedance to the flow of current, which is frequency dependent. The impedance of a capacitor decreases as the frequency increases. Inductors also offer impedance to the flow of current in AC circuits, but their impedance increases as the frequency increases. The combination of resistors, capacitors, and inductors in AC circuits can create complex impedance networks that affect the voltage and current relationships in the circuit. Analyzing AC circuits requires the use of complex numbers and phasor diagrams to represent the voltage and current waveforms. Ohm's law can be extended to AC circuits by replacing resistance with impedance. Impedance is a complex quantity that represents the total opposition to current flow in an AC circuit. It includes both resistance and reactance, where reactance is the opposition to current flow due to capacitors and inductors. The impedance of a resistor is simply its resistance value. The impedance of a capacitor is given by the formula Z equals 1 divided by J omega C, where J is the imaginary unit, omega is the angular frequency, and C is the capacitance. The impedance of an inductor is given by the formula Z equals J omega L, where L is the inductance. By combining these impedance values, we can calculate the total impedance of a circuit and use Ohm's law to analyze the voltage and current relationships in the circuit. Understanding Ohm's law and its applications is essential for anyone working with electrical circuits. It provides a fundamental framework for analyzing and designing circuits and for predicting their behavior. By mastering Ohm's law, you will be well equipped to tackle more complex electrical engineering problems.